Hello everyone. Today I am going to deliver my lecture on Kirchhoff's equation. What is a Kirchhoff's equation? The variation of enthalpy or internal energy with respect to temperature at constant pressure or constant volume is called Kirchhoff's equation. Let us derive the Kirchhoff's equation. Case 1. In terms of enthalpy. Let us consider a reaction in which reactant has an enthalpy H1 and product has enthalpy H2. Now, the change in enthalpy, that is del H equal to H2 minus H1. Now, differentiating this equation with respect to temperature at constant pressure, that is d del H upon del T at constant pressure equal to del H2 by del T at constant pressure minus del H1 upon del T at constant pressure. Let it be equation 1. Now, we know that the molar heat capacity at constant pressure will be equal to Cp, and Cp is equal to del H upon del T at constant pressure. Now, putting the equation, this value in equation 1. Then d del H upon del T at constant pressure equal to Cp2 minus Cp1. Therefore, d del H upon del T at constant pressure will be equal to del Hp or del Cp, equation 2. Now, equation 2 is called the Kirchhoff's equation. Now differentiating this equation 2, assuming that molar heat capacity is constant, then d del H equal to del Cp into dt. Now, integrating this equation with the limit del H1, d integration to the limit H1 to H2, d del H equal to Cp into integration to the limit T1 to T2 dt. Now, solving this equation, we get del H1 minus del H2 minus del H1 equal to Cp into T2 minus T1, or Cp or del Cp equal to del H2 minus H1. Now, H2 minus H1 by T2 minus T1. This will be the equation 3. Equation 3 is also known as Kirchhoff's equation. Now, Kirchhoff's equation can be also expressed in terms of internal energy in the similar way. So, by expressing the Kirchhoff's equation in terms of internal energy, we can get del E upon del T at constant volume is equal to del Cv. Here del Cv is the change in molar heat capacity at constant volume. Now, expressing this by integrating in the similar way, we can also get del Cv equal to E2 minus E1 by T2 minus T1. Both these equation 4 as well as equation 5 is also known as Kirchhoff's equation. Now, what is the application of this Kirchhoff's equation? With the help of Kirchhoff's equation, we can calculate the Cp, that is molar heat capacity at constant volume, as well as molar heat capacity at constant pressure also. We can also calculate the enthalpy change as well as enthalpy change as well as internal energy change. We can also study the variation of enthalpy with respect to temperature at constant pressure. Thank you.